It's called safe trees. In the northeast and southeast is the compact mid-rise. For the southwest, it's a compact high-rise. So then, if you can describe the land surface in the urban surface area more in detail, then we can do easily. It's possible to compare different research measurement results in different cities. And also, you can do imagine from one point is results to get the total emission for the whole city. Now, most of this research, we just according to the 1 point measurement, then you get to interpret to get the total emission for the whole city. That's get large of uncertainty. The wide regional scale, that's also why we want to do in the next step. And also, by the way, we have to one cooperative project that's supported by TRF and NSFC. We have cooperated with Dr. Sapte from Thailand Agricultural University. 30 days ago, I also to register the forest observing site in the northeast of Bangkok. So next step we want also to how to upscale from the point result to get the regional scale. That a flux that needed to one ability just for the heterogeneous of this land surface. So I will show the energy flux. First, about this radiation. I have to say, because we just to measure the total radiation from the top, from the roof of our office building. Then we had to use the cooperate with the scientific research from Finland, Helsinki University. We had used this model. We can to get about the reflected the upward solar radiation and downward the long wave radiation, and also upward long wave radiation. And also very important in the urban area is for the heat storage in the canopy layer. You can find that this is very large. It's the biggest, it can more than 600 watt per square meter. So that is for the monthly during the cycle of the radiation. So I just show for the winter, spring, summer, and fall. The first season you can find the heat storage in the city, in the upper canopy layer is very large. So it's very large. But sometimes this term is difficult to measure because, as we know, in the cities they have a large heterogeneous. So you need to put many sensor over different land surface, so over different location. But especially due to the budget of your project, sometimes it's difficult. So need to measure the 1 point or the 0 point to validate your model. Then we can get all of these areas energy budget. Until now, this work is just the primary result. We didn't need to compare with our measurement results, especially for the radiation convergence in this area. That is show the sensible heat flux during radiation in the summer and winter. As we show, because in Beijing, in the September is the rain season, you can find the sensible heat flux during the winter time is larger than the summertime. Because usually in the winter time in Beijing, you need a heating system. So the heat storage, the heat emission from the human activity is very large. So that's why for the sensible heat flux, winter is larger than summer. For the water vapor heat flux, the during the variation, you can find during the winter time, it is very small because Beijing is very dry. And also in recent years, they have snow in Beijing due to the global warming. Maybe just I think maybe 2010, they have some 2009 and 2010, they have the big snow in Beijing, according to my memory. But you can find in the summertime, I always say, because this is rainy season, you can find the water vapor and the latent heat flux can near 150 watt per square meter. So then that's I will show how about the carbon dioxide flux. That's what we put more attention on this flux. Around Thursday, we can around during the radiation of we are measuring the carbon dioxide flux over these 4 years based on the half-hour data during this study period. for the January to the December. Generally, we can do say you can find for each month the urban area is a net source of carbon dioxide. That is to say the carbon dioxide flux is always positive, no negative. For this, if you go to measure over this natural ecosystem like the forest and also grassland, usually absorb the carbon dioxide from the atmosphere. For the urban area, it's emission of the carbon dioxide from the surface to the atmosphere. So during variation of carbon dioxide is characterized by the clear pattern with two peak emission during the daytime and low emission during nighttime. And also we can find the winter time is larger than in the summertime. The daily carbon dioxide flux is partly mediated by the urban vegetation in the warm season. That is, warm season is related to the rain season, also the growing season, in summer. Then we can show the arranged the diurnal pattern of carbon dioxide for all of the day and the weekday and the weekend in the different season, winter, autumn, summer, and spring. The two peaks in the morning and in the evening correspond to the highest traffic amount of the day. That I think in Bangkok is the same because working during the morning, everyone come to the office. During the afternoon, they return to the home. The peak of carbon dioxide flux in the diurnal variation was significantly higher in the cold season, primarily caused by the high atmospheric carbon dioxide from the fuel combustion of the gas combustion for the domestic heating. Because in Beijing, just begin from 2007 for the clean air quality program. As we know, in Beijing, the pollutant now is still very zero. And you can find especially for the PM2.5, still the United Embassy in Beijing, they can show the concentration of PM2.5 every day in the Weibo side. But for our government, they have a lack of pressure for the air quality in Beijing. But however, because in China is still a developing country, so to decrease this concentration of PM2.5, they still need maybe at least 20 to 30 years. We can to reach the developed countries level. And also, from 2007, for the domestic heating, just can use it by gas, cannot use coal. That is what good for the PM10. But the exhaust from this heating system is also zero for the PM2.5. Around the diurnal pattern of the carbon dioxide flux or the weekend, just from the period during the 2000 of the game. So we can find that this pattern is totally different with usually in the 4 years. Because during that time, we have a strict tragedy control on the car use for the inhabitants in Beijing. And also, the cars from outer province is not, if you get special admission, it cannot run on the Beijing road. So the magnitude of carbon dioxide flux during the game was much lower than the outer times. The two peaks of carbon dioxide flux in the diurnal cycle was also not evident. So carbon dioxide this magnitude during the daytime and weekend usually except the larger than those recorded on the weekdays. So it's different with the year because due to the strict use of the car, that is can do the. However, I did to show because for this strategy can just last for 2 months, because they have the large effect on the human activity and for the transportation of the inhabitants in Beijing. So just after the 2008 Olympic finished, after 2 months, due to this car's use, you can find the flux is recover. It's the same as before. So this usually cannot last for long period. So then we can compare the frequency depression of carbon dioxide flux between the game and the same period in the other 3 years. We can find that during this negative for carbon dioxide, that is absorber of carbon dioxide, this frequency is more higher than the same period in the other 3 years. And also we can find the large positive flux, this frequency is lower than the other same period in the other 3 years. So I have to say because due to the heterogeneity of the land surface in the urban area, we can find the flux also have a relationship with the wind direction frequency. So in winter, the highest carbon dioxide flux were not consistent with the dominant wind or the prevalent wind, but corresponding to the intersection of two busy roads. That you see. That is in the winter time. I think the cars amount run on the road has a more important effect on what we have measured in our tower. In summertime, they measure the carbon flux in the west not much lower due to the carbon dioxide absorber by the vegetation in the park, I have to say. That is to show how about the difference of the wind direction. Then we can to estimate the total monthly and annually carbon dioxide emission from this area. So then I will show how about this monthly totally arranged the carbon dioxide flux. That is the same. We can find with no gap field in data set and with the arranged air temperature, we can find that the arranged monthly carbon dioxide was found to always positive regardless of the month. That is the source of the carbon dioxide. How about the relationship between the carbon dioxide flux and air temperature on the monthly scale? We can find a negative correlation between the arranged monthly carbon dioxide flux and the arranged monthly air temperature. So that's sometimes not just in Beijing. Loaders in Poland, also can find they have some good linear relationship. That is negative correlation with the air temperature. Just to say, sometimes we can try to find because sometimes it's difficult to measure every year by the EC. So sometimes we can try to find some easily measure the condition, measure the methodological parameter. Then we can estimate the carbon emission flux from the city area. Another is, I have to say, because based usually for the EC, usually they have some due to the power feature, instrument calculation or sensor malfunction, and also have due to some spec by the weather, like rainfall or snow. So, and also by the dust or the other condition of the sensor of optics. So you can find that the data gap always have larger than 30%. That is the good quality just 70 over 1 year. So if you to estimate the total annual carbon dioxide flux over this area, so you need to get a data gap theory. That is why to use this EC method to calculate the flux we need to do. And also your interval method doesn't need. You just according to the fuel consumption during the year, then you can estimate the carbon flux. So how to do the data gap theory? That is still under studied. First, I think less than 2 hours, just easily. We just use the linear interpolation. Then also we can cast the least ever on the annual flux totally. If the last 2 days, we use the linear dilation variation that's developed by the from the one scientist from the United States. But this just used for the natural ecosystem, like the grassland or it's not so high canopy layer. And also someone also argue is use this method is suitable for use the urban area. I just to say because until now we cannot find a more suitable data gap theory method to use the urban canopy layer. So that's why we still use this. Some scientists from European country they like to use the natural network to do this data gap theory. As we know, because in Europe, this is a developed country, and also for the, the condition, this is more stable. So, but in Beijing is changing very quickly, so we didn't use it. For the large gaps, we use multiplier interpolation. And totally, we can do annual the 4 years carbon dioxide exchange. The range is near 5 kilogram carbon, not carbon dioxide, carbon per square meter per year. So compared with the other, we get I will have to say it's not the biggest, but also is the largest. Can you say because I have to say they also have a relationship with which area you have set up your tower in the city. I will say in Beijing, our tower, this area is urban area is not located in the city center. If located in the city center, maybe it's large than this value. Oh, okay, that's